guys, today we are going to start with experiment 2, theorems of electrical circuit analysis. Okay, basically in electrical circuits theory you might have studied about the electrical theorems: superposition, Thevenin, Norton's, maximum power, one of maximum power transfer. The names what I am calling is the usually used theorems. Okay, you have 11 theorems in the electrical circuits part, but here we are going to do only the 2 theorems. We are going to perform experiment on with the 2 theorems, that is superposition and Thevenin theorem. Basically we are just verifying the theorems, okay, using the hardware. These theorems usually you verify with the software, no sorry, with the numerical. Okay, so here what we are going to do, we will solve the same circuit using numerical analysis, and then we will implement in the hardware and we will verify it. Okay, let us start the experiment. So as you know, the superposition theorem, so superposition is stated in any linear circuit containing multiple independent sources, either current or voltage source at any point may be calculated as algebraic sum of individual contribution effect of each source acting alone. Okay, so you know that at a time we will connect one source. Okay, and suppose if the circuit has one or more sources, so at a one time we will connect one source and short or open based upon the voltage source or the current source. We will take the individual current or voltage, and when we will sum it, it is equal to the total. Okay, it is equal to the sum of total current or the voltages. Okay, so this is the superposition theorem. Full way, if we define Thevenin theorem, it is nothing but any linear circuit containing several voltages and resistance can be replaced by just one single voltage in series with a single resistance connected across the load. That means if you have several sources like voltage source, so this we can replace by single voltage source, and many resistance we can replace as the total resistance. Okay, so this is nothing but Thevenin theorem. Okay, we will verify by using the hardware part, and there is if you go in detail. Okay, so here is the objective to apply the superposition theorem, to apply the Thevenin theorem. Okay, so we are not going to perform this part in this experiment. Okay, later on we will apply this apparatus. As you know, we need DC supply, 2 multimeters, group of resistance with 30 to 20 and 100, and the potentiometer. This is a new thing we will see. Potentiometer, what is potentiometer? Okay, so experimental procedure. Here you have the 2 voltage source. Here you can see 12 volt and 6 volt. So 12 volt and 6 volt we can use from the same device. As you can see here, this is the same device. We can use 12 and 6 from here. Okay, and select the appropriate meter ranges. Okay, so as this is the procedure, we will start. How we proceed with this is, so first we will measure total current in the circuit. Okay, we will apply 12 volt here, 6 volt here, power supply 1, power supply 2. Okay, we will take the whole current from here with this ammeter. Okay, so this is I naught, total current in the circuit. Okay, first part we will adjust. Okay, we will remove the supply 2. Okay, shorten this because this is a voltage source. When you replace voltage source, okay, it should be short circuit. When it is a current source, it should be open circuit. Okay, this is ammeter, not okay. So I am removing voltage source from here and making it short circuit. It is the IO1, suppose. Okay, so let us redraw the circuit here. So here, sorry, okay. So here it is 12 volt, here it is resistance, here it is resistance, this is ammeter, sorry, find ammeter. Here it is. So it is 12 volt and this is 6 volt. Okay, now what I am going to do is I am removing this and I'm making it as a short circuit. Okay, so this is gone. Now when we measure the current, it is I not 1. Total current here first, when we are measuring total current with help of this source, it is I naught. Okay, now this current, it is I naught 1 plus when we short this. Okay, and when I remove this part, and so this is 6 volt, so this is I naught 2, this is I naught 2, so this should be equal. So suppose whatever the value you are getting with I naught with the 2 voltage source, okay, it is I naught. Okay, with this voltage source it is I naught 1, and with this voltage source it is I naught 2. Okay, we will verify with the help of experiment. Let us solve the experiment. So these are the apparatus. Okay, we are not going to do this. Okay, we need 330 ohm, 220 ohm and 150 ohm resistance. Okay, 150 ohm is the load. Okay, now here you have two power supplies, 12 volt and 6 volt. So 12 volt is PS1 and PS2. Okay, so here you can see 12 volt, fixed 12 volt. I can use this part as a fixed 12 to provide the circuit, 12 volt to the circuit. Okay, and here I can use the variable knob and I can provide 6 volt here. Okay, let us set the value to the 6 volt by using multimeter. Okay, keep on the voltage. Okay, so let us measure the value as 6 volt. Okay, it is set. 6 volt is set. So okay, it is set to the 6 volt. Okay, now no need to change it. Okay, from here we can provide the 12 volt. Now we don't want 15, we want 12 volt. Okay, let us keep on 12 volt. Okay, and just remove this. So let us start the connection. You can see this is from 12 volt, it is going to 330, from 330 to 220, and 220 to the 6 volt, and from minus it is coming to the ammeter. Okay, 150 it is coming to the ammeter, and negative this common point all are grounded. Okay, so this is the circuit. Let us start the connection. Okay, it's 12 volt, it is going to 330, 12 volt to 330, and from 330 to 220. Okay, from 220 to 150, any point from here to here, or from here you can connect from any point. Okay, and from this point to the 6 volt. Okay, from here we are providing 6 volt to the 220. Okay, and we will connect ammeter after 150. Okay, this part from 150 it is connected to the ammeter, and ammeter, this all three are short. So ammeter, okay, another end of the ammeter is grounded, common. So this is the total circuit. Okay, from this point to the 330. Okay, from this point it is going to 220. Okay, from here or here you can connect it to 150. Okay, from this point to 6 volt, and from 150 it is connected to the ammeter. Okay, we already set this to 6 volt. volt is given to 220, okay, and this point to the ammeter, and from ammeter it is connected to the common. Okay, this 29.7 is total current. So here total current we are getting as I naught. So you can write I naught is equal to 29 point, how much it is, 29.7 milliampere. Okay, this is I naught. We don't want voltage here, so this is with, you can tablet here, okay, with PS1 and PS2. So it is how much, 29.7 milliampere. Now what we are going to do is, next part, now you can observe in the tabular form I naught with PS1, only PS1, and we will remove PS2. Okay, so make correction as PS2, then PS1. Okay, only PS1. With PS1 means how much, only 12 volt. Okay, so we will remove the 6 volt from the circuit. So 6 volt, this point is here. From this point we remove 6 volt, that means from 220 it will go directly to the common. So let us remove this 6 volt and I will connect it to the common point. Okay, remove this and connect it here, connect to the common point, and this is, so you can see this is I naught 1. So here I naught 1 is 17 milliampere. Okay, this is I naught 1. So it is on the milliampere. Okay, 17 milliampere. With PS1. Now what we do is, we will remove this and connect on 6 volt. Sorry for this, this one becoming obstacle. No problem. Okay, just I will remove this and I will connect to the from here. I have removed and I have connected here. So that means this is only 6 volt is common here, and this is short. So how much it is? 12.7. So how much it is? I naught 2 is, how much it is? 12.7, which is 12.7 milliampere. Add these two, so it will be I naught 1 plus I naught 2, which is equal to I naught. Okay, so here we prove the superposition theorem. You go to the next page, you can find the circuit. Okay, so here you can do the calculation. Okay, just remove PS1, okay, and sorry, PS2, and calculate. So with the total, just calculate I naught, and then I naught 1 and I naught 2. Okay, so let us calculate here. I will not calculate, I will just give you the hint. Okay, you can calculate by yourself. This is PS1. PS1, it is I naught 1. Okay, with this you can calculate I naught 2, 6 volt. You can calculate PS2, I naught 2. Okay, so just calculate this. I naught equals to I naught 1 plus I naught 2. This is the theoretical part. Okay, problematically we solve it. We implement it on the circuit and we got the practical part. Okay, theoretically, yes, you can solve it. Now the next part is Thevenin's theorem. Okay, Thevenin's theorem. Okay, as you know, we will remove all the resistance and replace it by one resistance, all the sources, and we will replace it by one source. Okay, so just that is called as the V Thevenin and R Thevenin. So we will calculate V Thevenin and R Thevenin. So let us. So we have to calculate here V. We have to calculate V Thevenin and R Thevenin. So to calculate V Thevenin, we have to remove, replace it by all this by all the voltage source, and this by one resistance. Okay, so let us see the circuit here. Okay, so 150 is the load resistance. Okay, R Thevenin and I naught. Okay, let us start the connection. Okay, from 6 volt same way, from 6 volt to 330, and from 330 to 220. Okay, it is, sorry, it is 10, right? To 12. Okay, 10 and 6 to 220. Okay, from this point you can connect to the 150. Here we are just calculating voltage. Okay, let us calculate the voltage here. So here, this from this 2 point, this from 220 or 320, anywhere if you connect from this point to the common in the power supply, then we will find the total voltage, that is V Thevenin. V Thevenin is 10 here. V Thevenin is 10 volt. Okay, now let us take the total resistance. Okay, so here you can find total resistance. Just click on resistance. Okay, no need for the power supply. Okay, why it is not coming? Just let us. Okay, just switch off the supply. No need for the supply because we are calculating only total resistance. Okay, calculate total resistance from 330 and 220. I will connect from these 2 points. Okay, these two will be in the series, and from these two it will be in the series like this. Okay, so this point and this point I will connect a ohm meter. So here we can find the total resistance. Okay, so let us see. 220 I have connected like this, and this from 220 and 330. Okay, from 330 to this point, 220 to this, and 330 into this fashion. It is actually parallel. Okay, not series. So connect the ohm meter in any two point. Okay, 330 and 220. Connect to the ohm meter at this point. Okay, just keep on kilo ohm. Okay, not in the volt. Just keep on kilo ohm. Okay, now let us connect the ohm meter here and here. Okay, so now the total resistance is 131.4. so 131.4 is R Thevenin. So we calculated here V Thevenin and R Thevenin. Okay, R Thevenin, it is 131.4 ohm, because here it is brothers, you can see here. Sorry. So this is ohm. Okay, when you come to the lab, you can find This is ohm. It is kilo ohm here, but here it is only ohm. Maximum value is here ohm. So this will be 2 kilo ohm. Okay. Here it is 200 ohm bus. So make sure don't make yourself confused. Okay. Now I will use the potentiometer. This variable knob. It is used. It is potentiometer. Here we can set the resistance. We can vary the resistance value. What is the resistance? Total resistance value we have now. R Thevenin it is 131.4 ohm. Okay. I will take the resist 470 potentiometer. Okay. Potentiometer with the value of 470, and I will set the value of R Thevenin, okay, by using the potentiometer. Next, okay, now just connect it crossway. Okay, just vary from here. So vary the knob. Vary the knob. This. Okay, so 470 is the maximum value here. So when I vary from here, you can set the resistance value to 131 from here. Okay, so now we set the resistance value because we don't have exact value of this. So just I change using the potentiometer. It's fine. You can use variable potentiometer for variable resistance. Okay, 131 it is set. Okay, now just connect with the 150 at the load resistance. Okay, Thevenin theorem. What is Thevenin theorem? We find total voltage as 10 volt and total resistance as 131.4. So now I have set the by using potentiometer I set the resistance value of 131, and now I will make the voltage how much? 10 volt. Now we can vary the voltage. Okay, so voltage here with Thevenin is how much? 10 volt. Okay, we will connect to the voltmeter and we can set the value. This is R Thevenin. This is just make the correction. It is 150. Okay, from here and from this point I will connect to the variable voltage and set the value to 10 volt. Okay, let us set the value to the 10 volt. Off. Let us make it on first. Make the voltage value 10. Okay, it is 10, 10, 10, 10. Done. 10. Okay, done. So now we set the Thevenin voltage to 10 volt. Okay, make the circuit. Just connect the Thevenin and R Thevenin in series with this is 150. Okay, make the correction. It is 150. Sorry, 150. Okay, 150 ohm. Because load resistance is 150. PS1 is R Thevenin is 131. Both are in series. Okay, let us connect from 10 because now we set to the 10. Okay, previously it was 6. Now we set to the 10. From here to the R Thevenin. Okay, from R Thevenin to 150. Okay, here I am connecting in the cross fashion. Okay, to the 150. Okay, from 150 to the ammeter. So because we are calculating the current here. So let us just remove that. Clear. Okay, mess. No, mess now. So now the current is 35.6. Okay, let us make sure. Okay, the connection. Just make sure the connection. Okay, it is 10. We already set the value to 10 volt. Okay, so now the total current is I naught is 35.6. so I naught is 35.6. Okay, so VThevenin is, just fill the tabular form. You can fill the tabular form like VThevenin, it is 10 volt, and RThevenin is 131.4, and I naught is 35.6 milliampere. Okay, so these are measured values, and here it is calculated values. So for doing the calculation, just go to the circuit and solve it, and you can verify. Okay, theoretical and the practical part. Just fill the box. 10 volt, 131.4 milliamperes, and I notice 131.4 ohm, not milliampere, it is 35.6 milliampere. Okay, okay, and do the calculation part. If you conclude our experiment 2, see here, consider the same circuit. RL is 150 ohm. It is required to calculate the current I naught using Thevenin theorem. Okay, so to do with the Thevenin theorem, just draw the circuit here. Okay, and do the calculation part. Okay, if you have any doubt, you can ask me. Okay, to my mail, and we can perform the same experiment in the lab in the week 3 tomorrow, inshallah. And brothers, if you subscribe the channel, you can view the new videos for your better understanding. Okay, so take care, bye bye.